Imagine you are an engineer, a brilliant one, and someone offers you the most ambitious contract in the history of science. Design a machine that blocks gravity, just for one room, just for 1 second, full funding, best team, no deadline. You can use any material ever discovered, any energy source that exists. You would fail. Not because the engineering is hard, not because the budget ran out, but because the contract itself is asking you to do something that the universe does not allow, at a level so deep, it isn't even a law you could imagine breaking. It's something more fundamental than a law, and the reason is sitting right beneath your feet, in the structure of space and time itself. Most people, when they hear that, assume it means gravity is simply very strong, the strongest force, impossible to overcome. But that's not why. That's actually a misconception, and the real reason is far stranger, far more unsettling, and in a way, far more beautiful than it's just very powerful. To understand it properly, we need to start with something that sounds completely unrelated. We need to start with a question about falling. What does it actually feel like to fall? Not in the dramatic sense, not off a building, just freely. Imagine you are in a sealed box, floating in space, far from any planet, nothing pulling on you. You feel weightless. Objects you let go of hover beside you. Your feet press against nothing. It feels like freedom from gravity, and it genuinely is. Now imagine a different box, same sealed walls, no windows, but this time you are inside an elevator on Earth, and the cable has just been cut. You and everything in that elevator, the coffee cup, the papers, the air itself, fall together at exactly the same rate. Your feet lift off the floor. The cup floats. If you let go of anything, it just hangs there beside you. From the inside of that box, it is completely physically identical to the first scenario. You cannot tell the difference. There is no experiment you can perform inside the box that tells you whether you are in deep space with no gravity or plummeting toward the ground in Earth's most powerful gravitational field. That moment, the recognition that those two situations are physically identical, is the key that unlocks everything about why gravity cannot be switched off. It took the world's greatest physicists centuries to notice it clearly, and when one person finally did in 1907, he later called it the happiest thought of his life. The insight was this: if you cannot feel gravity when you fall freely, then maybe gravity isn't a force grabbing you at all. Maybe what you call gravity, that familiar pull, is actually something else. Something you only feel when something stops you from falling, like a floor, or a chair, or the ground. Notice how your intuition resists this. It feels like the earth is pulling you down. It feels like a force acting on you. But here's the test. The moment you step off a ledge and fall freely, that feeling vanishes completely. The force, whatever it was, disappears the instant you give in to it. Real forces don't behave that way. If you push against a wall, the force is there whether you push back or not. Gravity seems to dissolve the moment you stop resisting it. That is a very strange property for a force to have. Here is what is actually happening. Every object with mass, every planet, every star, every grain of sand does not reach out across empty space and pull on things. Instead, it does something to the space and time around it. It curves them, bends them, the way a heavy ball placed on a stretched rubber sheet sinks into the surface and creates a depression. Except the thing being curved isn't a rubber sheet, it's the actual fabric of reality, the geometry of space and time itself. And when an object moves through that curved geometry, it follows the most natural straight-line path available to it. It doesn't get pulled. It just moves naturally. The curved geometry does the work. The Earth doesn't pull the moon. The Earth bends the space-time the moon moves through, and the moon follows the gentlest curve available, which happens to look from the outside like a circular orbit. This is a simplified explanation to make the core idea intuitive, but it changes everything about the original question. Because now, when you ask, why can't we block gravity? You're not asking why a force is too strong to stop. You're asking why you can't step outside the geometry of space and time. You're asking why you can't build a room that exists outside of reality's structure. And the answer to that is obvious once you see it. Any room you could build, any material you could use, any particle you could arrange, is already inside the geometry. It is made of the geometry. There is no outside. Every atom in your hypothetical gravity-blocking material is itself inside curved spacetime. It is itself subject to that curvature. The thing you want to use as a shield is already part of the thing you're trying to block. It's like trying to build a wall against the direction called downward, using bricks that already know which way down is. Compare this to the other forces, electromagnetism, which produces both electric and magnetic effects, can be screened. You can put a conducting shell around a region, and the electric field inside drops to near zero. That works because the charges in the material can rearrange themselves to cancel the incoming field. But gravity has no negative counterpart. There is no negative mass. There is no anti-gravity charge that could rearrange itself to cancel a gravitational field the way electrons cancel an electric. Every kilogram of your shielding material adds to the gravitational effect rather than subtracting from it. You cannot neutralize a field with a material that only ever adds to it. And here is the thing about that. It isn't an accident. It's a consequence of gravity being tied to mass, and mass being always positive. Energy is always positive. And since gravity responds to all energy, all mass, all movement, all heat, everything that could ever constitute a barrier is simultaneously a source. The wall you build to block gravity is itself generating gravity. Now, here is the part most people have never thought about carefully. Gravity is often called the weakest force in nature and measured at the scale of individual particles. This is accurate to a degree that is almost impossible to communicate. If you compare the gravitational attraction between two electrons to the electromagnetic repulsion between them, the electromagnetic force wins by a factor of roughly 10 to the power of 42. That is a 1 followed by 42 zeros. Gravity, at the particle scale, is not just weaker. It is so incomprehensibly weaker that physicists genuinely do not understand why. This is called a hierarchy problem, and it remains unsolved. But here is the twist that doesn't get said enough. Despite being unimaginably weak at small scales, gravity is the force that shaped every large structure in the observable universe. Every galaxy, every star, every planet capable of holding water on its surface. Electromagnetism is stronger, yes, but large objects are generally electrically neutral. Positive and negative charges cancel. Gravity has no such cancellation. Every kilogram attracts every other kilogram, always, with nothing pulling the opposite way. So while electromagnetism dominates at the scale of atoms and molecules, gravity wins at the scale of worlds. The weakest force built everything you can see at night. Wait, if gravity is geometry, not a force, then what are we actually feeling when we stand on the ground? This is where the idea becomes genuinely destabilizing. When you stand still on the surface of the earth, you feel weight pressing through your feet. You feel pulled down. Your intuition tells you gravity is acting on you, doing something to you, exerting a force on your body. But in the framework of general relativity, that sensation isn't gravity. That sensation is the ground stopping you from following your natural space-time path. Your natural path, the path you would take with no forces acting on you, is to fall freely, the same way that elevator fell. The ground interrupts that path. It pushes up on your feet, accelerating you away from freefall, and that upward push is what you feel as weight. The person standing still on the Earth's surface is not in a force-free state. The astronaut orbiting overhead, who feels weightless, who floats inside their capsule, that person is closer to a force-free state than you are. They are following their natural geometry. You are being forcibly deviated from yours 400 times every second because the ground won't let you fall. This feels wrong at first. It runs against every intuition built by a lifetime of experience. But the mathematics is unambiguous, and, more importantly, the evidence is unambiguous too. There is a technology you almost certainly used within the last 24 hours that only works because this picture of gravity is correct. The GPS network, the system of satellites that lets your phone locate itself on a map, requires precise timing. The satellites carry atomic clocks, but those clocks run at a slightly different rate than clocks on the ground for two reasons. One is their speed, which slows their clocks slightly due to the effects of motion. The other is their altitude. Up in orbit, the Earth's mass curves spacetime less severely than it does at the surface. Less curved spacetime means time flows faster. GPS satellites gain about 45 microseconds per day just from this gravitational effect. If the system didn't account for it, if engineers had built the network as though gravity were irrelevant to time, the position errors would accumulate at about 10 kilometers per day. Your phone would place you in a different city. The geometry of space-time is not philosophy. It is an engineering constraint, and it is corrected for in every GPS device on the planet. There is another piece of evidence. Smaller, faster, stranger. High in the upper atmosphere, cosmic rays collide with air molecules and produce particles called muons. Muons are unstable. They decay in a tiny fraction of a second, so short that even traveling near the speed of light, they should disintegrate long before reaching the ground. And yet, muon detectors at sea level register them in large numbers. They survive. The reason is time dilation. Moving at high speed through curved space-time slows the muon's internal clock relative to ours. To the muon, only a brief moment passes. To us, enough time has passed for it to travel all the way to the ground. The muon doesn't know about relativity. It doesn't need to. The geometry takes care of it whether the muon understands it or not. And you are subject to the same geometry for the same reason, whether you understand it or not. Now there is a harder question underneath all of this. A question that physics has not yet fully answered, and which makes the gravity cannot be switched off problem even deeper than it first appeared. Every other force in nature has been successfully described using quantum mechanics. Electromagnetism was the first, then the weak nuclear force responsible for radioactive decay, then the strong nuclear force which binds the nucleus together. All of them fit into a single framework, the Standard Model, which describes forces as being carried by a specific particle. Photons carry electromagnetism. Gluons carry the strong force. W and Z bosons carry the weak force. The model is the most precisely tested theory in the history of science. Some of its predictions have been verified to 11 decimal places. Gravity does not fit this model. Theoretically, there should be a particle, called the graviton, that carries gravity the way photons carry light. But no graviton has ever been detected, and every serious attempt to build a quantum theory of gravity runs into mathematical disasters. Infinities that cannot be resolved, equations that predict nonsense at the smallest scales. The two great pillars of modern physics, quantum mechanics and general relativity, are both spectacularly confirmed by experiment, and they are fundamentally, stubbornly incompatible with each other. Reconciling them is considered the deepest unsolved problem in all of fundamental physics. What this means for our original question is significant. We do not have a gravity shielding problem because we lack clever engineers. We have it because we do not yet have a complete theory of what gravity actually is at the most fundamental level. We can describe it. We can predict its effects with extraordinary precision across cosmic distances. We can correct for it in satellites. We can detect ripples in it from black holes colliding over 1 billion light-years away. And we still cannot fully explain, at the deepest quantum level, what exactly is happening when mass curves space-time. The mechanism is missing. The why beneath the what is still open. Think about fire. Humans have used fire for hundreds of thousands of years, for warmth, for cooking, for forging metal, long before anyone understood that fire is a rapid oxidation reaction, a cascade of molecules breaking apart and reforming while releasing photons. The use came first, the understanding came later, and it was hard-won. The same is true of gravity. We have used our understanding of it to navigate, to launch spacecraft, to predict ocean tides for thousands of years. We have extended that understanding far enough to build functioning GPS systems and detect gravitational, and we still do not have the final theory. We are somewhere between using fire and understanding combustion, closer to understanding than we have ever been, but not there yet. So when someone asks why gravity can't be switched off, The full answer has at least three layers. The first is practical. There is no negative mass, nothing to cancel the gravitational effect, and any material you use as a shield is itself a source. The second is conceptual. Gravity is not a force radiating from a source into empty space. It is the curvature of the space itself, and you cannot put a barrier between yourself and the geometry you are already inside. The third is honest. We don't fully understand what gravity is at the quantum level, which means we cannot even be certain what switching it off would physically mean in a complete theory of nature. What we can say with certainty is this: gravity is not a machine. It is not a field generated by a generator somewhere that could be turned off if you found the right switch. It is a consequence of the most basic fact about reality, that mass and energy exist, and that their existence shapes the structure of space and time, and that everything which exists is inside that structure. You cannot exempt yourself from it any more than you could exempt yourself from existing in 3 dimensions of space. You could not build a room in which left and right don't apply. You cannot build a room in which the geometry of space-time doesn't apply. The room is made of space-time. You are made of it. There is a moment when you really sit with this, where something shifts. You realize that the feeling of heaviness in your body right now, the weight of your own limbs, the pressure on whatever surface you're resting on, is not gravity acting on you. It's the surface of the Earth acting on you, holding you back from the path you would naturally take through the geometry of the universe. Gravity isn't pressing you down. Gravity is the shape of the space you're inside, and the floor is what's pushing you away from the direction that shape points. You are not being held down.